Good morning, students. In today's session, we will learn how to install and configure the Arduino IDE for programming ESP8266 based Node MCU boards. This is an essential step before developing IoT applications. By the end of the session, you will be able to install the required software, configure the board package, upload the programs, and troubleshoot common issues. The first step in IoT development is installing the Arduino Integrated Development Environment, commonly called Arduino IDE. Students should download the latest Arduino IDE 2.x version from the official Arduino website. The newer version provides better debugging, auto-completion, and board management support. Once installed, launched, launch the IDE and verify that it opens correctly. By default, Arduino IDE supports only Arduino boards. To program ESP8266 boards, we must add ESP8266 Board Manager URL. Open the Preferences menu and paste the ESP8266 package URL into Additional Boards Manager URLs field. This allows Arduino IDE to download the required board definitions and libraries. After adding the URL, open the Boards Manager and search for ESP8266. Select ESP8266 by ESP8266 Community and install it. This package contains all the necessary drivers, libraries, and board configurations needed to program ESP8266 device. Once installation is complete, we must choose the correct board type. For most Node MCU boards, select Node MCU 1.0 ESP12E module. Selecting the correct board ensures proper communication between the IDE and the hardware during program upload. Proper board configuration is important for successful programming. Common settings include flash size, CPU frequency, upload speed, and port selection. The COM port should match the USB port assigned to the Node MCU board. Incorrect settings may result in upload failures or unstable operation. Some ESP8266 boards use USB communication chips such as CH340 or CP2102. If the board is not detected by the computer, the appropriate USB driver must be installed. After installation, reconnect the board and restart the Arduino IDE if necessary. Once the environment is configured, we can test the setup using a simple Wi-Fi scanning program. This program scans nearby wireless networks and displays them in a serial monitor. Successful execution confirms that ESP8266 board, drivers, and IDE are functioning correctly. After writing or loading the program, click the Upload button. Open the serial monitor and set the baud rate to 115200. If nearby Wi-Fi networks are displayed, the board has been successfully programmed and is communicating correctly. Students may encounter issues during programming. If the upload process gets stuck at connecting, try holding the flash button, reducing the upload speed, or changing the USB cable. If the board is not detected, verify the driver installation and check device manager. Compilation errors often occur when the wrong board is selected. After successfully configuring the ESP8266 environment, students can proceed to advanced IoT development. Useful next steps include installing libraries such as ESP8266 Wi-Fi and ESP8266 web server, exploring OTA updates, using file systems like SPIFFS, and learning advanced development workflows using platform IO.